This is a rare case in the SAT where we do not have the formula for the geometry that we need to do. So they talk a lot in the beginning of the section when they give you those formulas about volume and area and different lengths, especially with triangles, but surface area does not come up as a formula that they give you. Basically, you just need to memorize what the concept is, and it's fine, and you can kind of derive the formula because different shapes have different formulas, and the concept, though, is going to always bring you back to the same place, right? It's the area of the faces. So think about a cube, right? A cube is a die, right? So it's a box, and it's a box where all the faces are the same. So I'll kind of go behind here. So, well, you might know the formula in kind of its own terms, but I don't think that that's particularly helpful here because we have such a weird way of representing the surface area, right? 6 times a over 4 squared. Here's a good example where, like any shape that you would encounter in real life is not going to have a dimension of 6a over 4 squared. Like, this just doesn't make any sense if we've ever just lived in the real world. So the solution to that problem is to bring us back to something that's more normal, right? Arithmetize. Pick a number for a so we don't have to deal with this weird situation. Now, normally we pick really easy numbers like 0s and 1s or even 2, but I think this formula kind of pushes us pretty solidly towards a very easy number for math, right? So my guess here would be to make a equal to 4. Because then all the math works out really well, right? 6 times, in this case, 4 over 4 squared. Well, 4 over 4 is 1. So 6 times 1 squared is just 6. So this is telling me that the surface area of this cube is 6. 6, I don't know, cubic or square centimeters or something. I don't know the units, it doesn't even matter. But now think about what that means. That means the area of all the faces of the cube is, the sum of that is 6. And a cube has 6 faces, right? The top and bottom, the left and the right, and the front and the back. So 6 faces. So that means each face is equal to 1. And a lot of times with 3-dimensional shapes, it's helpful to draw them in 2 dimensions, right? So especially because we're dealing with surface area, so we're thinking of the surface, right? So the area of one face is equal to 1. And what they want is the perimeter of one face of the cube. So by trying to look at it in 2 dimensions, we kind of remove the complexity and we can get down to a place that's just easier for our brain, right? 2 dimensions is easier to think about than 3. So we need to get the perimeter. And in order to do that, we need to get the side length. So if the area is 1, we know that the area of any box is length times width, or any square, any rectangle. Because it's a square, the length and the width are the same, so what times what gives me 1? Well, there's only one possibility. 1 times 1 gives me 1. And if they want the perimeter, then we need all the sides added up. So in this case, that's 4 1s, so the perimeter is equal to 4. Now look at our answer choices, right? We don't have 4 as an answer, but we remembered from the start that a was equal to 4, so we plug that into those answer choices and we can see which one gives us the perimeter that we want. So a lot of people make the mistake of kind of just like jumping to choice C here because they see the 4, but remember, a is equal to 4. So 4 over 4 is 1, no. B is 4, but this is going to be 16, and this is going to be 24. So arithmetize works out. We just can't jump to the conclusion. We just need to like put the number in and show the work and just do it. But I really think that this question is easier with arithmetize. Like any geometry question, you're just better off having dimensions because then you have numbers. And when we have variables and numbers, we've got to think about 2 kinds of things, right? The letters and the numbers, how they interact with each other. And there's different rules for letters in math than there are for numbers. So it's just giving our brain more to think about. Why do that when we can just pick a number for the variable and just let it be just all numbers. And the reason we know from the start that the value of A doesn't matter is, look, A is in the question, A is in the choices. It is never something we're asked to solve for. It is a placeholder that's going to carry through the question. So all arithmetize is replacing the placeholder with a number, using that, and doing the problem anyway. So it's the same work we would have done with a variable, but it's much easier, and that means less careless mistakes and probably just less staring at a question, because you kind of can instantly start to get to work instead of trying to worry about equations and everything like that. Arithmetize when you can. Life will be easier.